This video is going to cover select problems from your 9 weeks review for pre-calculus. Here on the screen, I have the first problem I'm going to do, number 4. This is in the first section from 1 through 6, asking whether or not the sequence is arithmetic, geometric, or neither. Okay, so a couple things here on the side. If you want to take notes, I highly recommend it. Just a reminder that in arithmetic sequence, you're looking for a common difference, and here's kind of a formula I'll go over in a bit. And for geometric sequence, you're looking for a common ratio. Okay, so you can see here I kind of labeled the terms. We have ace of 1 is your first term, ace of 2 is the second term, ace of 3 is the third term, and so forth. Okay, so when you're looking for an arithmetic sequence, you want to subtract the second term minus the first term, and that should give you a number. If it is an arithmetic sequence, then if you keep on going, so let's say you do this term minus this term, so third term minus second term, it should be the exact same number you got for ace of 2 minus ace of 1. So in general, and I think a picture might help, if you're going from, use a different color, from here to here, so from 2.9 to 4.8, you're going to be adding some number, okay? From here to here, you're adding the same number, and that would mean that it's arithmetic if it's the same all the way across, okay? So we have to check for that. So one way to check for that is just to subtract using the formula. So I'm going to go ahead and do that right now. So if we're assuming that this is a arithmetic sequence, then we can say that D, which is the common difference, would be equal to ace of 2 minus ace of 1. So ace of 2 is here, so it's going to be 4.8 minus ace of 1, which in our case is 2.9. Okay, so if we subtract this, we should get a little bit under 2, so 1.9. Okay, now assuming that this is an arithmetic sequence, we can continue to check the next term. So far from here to here, we have added 1.9. So if this is also 1.9, then we're probably going to have an arithmetic sequence, okay? So to check, we're going to subtract. So we're going to say ace of 3. So ace of 3 would be our third term. So 6.7 minus ace of 2, which is our second term, 4.8. And if you subtract that, you can use a calculator or just, do it in your head. It's again a little bit under 2, which is 1.9. So we can see that so far so good. Okay, we can try it one more time just to double check. So let's do the last one. Not last one, but the third one, which would be your next term. So 8.6 minus 6.7. I'm just going, backwards. If we subtract this, again, it's a little bit under 2, 1.9. So it looks like this is an arithmetic sequence, okay? But just for the sake of showing you all the geometric, let's go ahead and try that one as well. The geometric sequence will be a sequence that has a common ratio. So you're multiplying this term times something, so times some number. I'm going to use a different color. That's kind of hard to see. You're multiplying 2.9 times something to get this number. And then the same thing here. You're multiplying by that same number to get this number. So let's see if that's true. To check, we were going to divide. So let's try using the first one. So R, which is our common ratio, would be equal to ace of 2. So ace of 2 again is the second term. So 4.8 divided by the first term. So divided by 2.9. And we're going to see what that gives us. I don't know what that is on the top of my head, so I'm going to use a calculator. So I'm getting 4.8 divided by 2.9 is giving me approximately 1.655. Okay? So it's approximate. So if this is a geometric sequence, that means that from 4.8 to 6.7, I should be multiplying by this. So let's check one more. Let's scroll down just a little bit. So we're going to check the next term. So a sub 3, which is our third term, 6.7 divided by a sub 2, so 4.8, and let's see what that gives us. So 6.7 divided by 4.8, and that gives us approximately 1.4. So you can see here, these two things do not match. So right off the bat, we do not have a geometric sequence, and that means that the answer for number 4 is that this is an arithmetic sequence. So let me go ahead and do that. So this is going to be an arithmetic sequence where our common difference, so D, is equal to 1.9. Okay, so with that in mind, we're going to go ahead and do one more from this section. I'm going to try to go a little bit faster because I don't want this video to be, eternal. So let's look at number 3 now, and I'm going to try to get all this on the screen here. All right, so now we're looking at a different pattern of numbers here. So we're going to go ahead and try the arithmetic sequence first. I mean, sometimes you can kind of tell just by looking at the numbers, but for the sake of practice, let's try them both. So if this was an arithmetic sequence, okay, if this was this one, that means we would have a common difference. So a sub 2 minus a sub 1 would give us the same thing as a sub 3 minus a sub 2. So the second term in this one would be 10. First term is negative 2. So 10 minus negative 2 looks like that would give me 12, because remember, two negatives make a positive. And this should be equal to the next one. So a sub 3, which is negative 50, minus a sub 2, which is 10, is going to give me negative 60. So right here, right away, we can see that this is not going to work. So it's probably not going to be an arithmetic sequence. Okay, so let's go ahead and try the geometric. So for geometric, we need to find a common ratio. And the common ratio is a sub 2. So again, we're going to look at 10 divided by a sub 1. So divided by our first term, negative 2, which comes out to negative 5. Okay, so if that's true, then that means the next number should also be, a multiple of negative 5, moving from 10. So a sub 3, so negative 50, divided by a sub 2, which is 10, is negative 5. So far we have 2 check marks. To kind of make the process go by faster, for those of you who just, don't like doing all this work, let's just kind of look at the pattern here. So from here to here, we multiplied by 5. Negative 5, sorry. From here to here, we also multiplied by negative 5. So far, our work is checking out. Let's go ahead and try the next one, see if we can get away with a step here. So negative 50 times negative 5 is going to give us 250. And if we keep going, again, times negative 5, we get negative 1250. So it looks like this one is a geometric sequence, okay, with a common ratio, so R, of negative 5. Okay. Now, if this doesn't work for, let's say you have a different problem and both of these were to come out as x's, then the answer would be neither. Okay, so be careful with that, because I believe there is one or two that are neither. Sometimes there's just patterns that are nothing at all. Okay, so just keep that in mind. Let's go ahead and move on to the next section. So I believe it's 11 through, I don't know, 11 through something. But in this one, I'm going to cover how to do arithmetic sequences. Let me try to get that centralized there. I chose number 11 because it has some of the bigger numbers, and I know that's what we tend to not like. So for this one, we're going to use the formula a sub n is equal to a sub 1 plus d, and then n times n minus 1. So just like before, I'm going to go ahead and label my ace of 1 because I do need that. I need that here in this part, okay? And ace of n would be our A26. So this right here is our ace of n, okay? N would just be the 26. So this is n. I'm just labeling everything right now so I know what everything is, okay? And my D is the common difference. So for D, we do have to calculate this. Remember from before that D is equal to the second term minus the first term. So it's ace of 2 minus ace of 1. In this case, ace of 2 is going to be the second term, so negative 176 minus the first term, 24. So if I subtract this, they're both negative, so you actually add them, which gives me negative 200. Okay, so D equals negative 200. So now that I have everything, all I really have to do is plug it in. So let's go ahead and do that. We have ace of n, so ace of 26 is equal to ace of 1 is our first term, so that's 24. Okay, 24 plus the common difference, which we calculated, and that came out to negative 200. So negative 200 times n minus 1. So our n was 26, okay? And if we subtract 1, I'm going step by step here, okay? It should give us something else. So from here, I just have to simplify. I'm going to go ahead and do the inside first. So if I do this part first right here, okay, that's going to give me 25. And then all this just kind of stays the same. Let me rewrite it. Okay, 26 equals 24. Oh, plus negative 200 times 25. So the next step would be to multiply. If you want to put this in parentheses because it just looks neater, sorry, you can do that as well. So let's see, we multiply 200 times 25. That's going to be, before 500, no, 5,000. Sorry, I'm trying to do mental math, guys. Yeah, 5,000, I was right. So this is going to give us negative 5,000. Can I still have that 24? And I realize that a lot of you have, calculators that might be able to do this all in one step, but arithmetic is a good thing to practice. So that's why I'm going step by step. So 24 minus 5,000 is going to give us, since 5,000 is bigger and it's negative, you're going to subtract and keep it negative. That's negative 4,976. And that is the answer to this problem. Okay. All right, moving on. I believe the next part is going to be geometric sequence formulas. Yep. So for this one, let me move up a little bit. I chose number 14 because there is a fraction there, and I know how much we love fractions. The formula for this one is going to be ace of n is equal to ace of 1 times the common ratio to the power of n minus 1. Okay. I recommend you write all these formulas down, and you don't have to memorize them, but more or less know the pattern to it. Okay. So for this one, let's see, we need ace of n. So our ace of n is right here. Okay, we need ace of 1. Ace of 1 is always your first term, so it's going to be negative 2. And we need n, so n is just 10. So this right here would be n is equal to 10. Okay, and we need r. So our r stands for the common ratio. So just as a reminder, r is equal to ace of 2 divided by ace of 1. In other words, what did I multiply the first term to get to the second term? Okay, so we're going to calculate r first because we have some fractions and that's always fun to work with. So ace of 2 is going to be your second term, in this case, negative 2 over 3. So negative 2 divided by 3 divided by, because you have to divide, our first term. So again, a sub 1 is -2. Okay, so I would rather you not do decimals here because this one's actually not that bad. We do something called keep to flip change. You guys know it as KFC. Okay, so we're going to keep the first fraction, so -2/3. We're going to flip the second one. So this one right here, this is the same as -2/1. Okay, so we're going to flip that one. So now it's 1/-2, and we're going to change this division to multiplication. And what that does is it helps us simplify this a lot nicer. You can see that the -2's are equal to 1, so we can cross those out. And we're just left with 1/3. So all that work just to get R, okay? So R is 1/3, okay? So let's go ahead and write this out. We have a of 10, okay, is equal to a of 1 is -2. We already have that right here. So -2, okay, times our ratio. So I'm going to put this in parentheses because I don't want to confuse multiplying 1/3 with 2. Remember, 1/3 it has a power, so we do have to raise it to the power. To the power of 10 minus 1, because it's n minus 1. So this part right here is the n minus 1. And then I'm just going to go step by step. So the -2 stays there. Okay, the 1/3, I'm still going to leave it there, because again, I'm going step by step here. So 1/3, the first thing I want to work with is that exponent. So PEMDAS tells us to work with parentheses and then exponents. We do have parentheses, but there's really nothing in there but one number. So we're going to work with the parentheses. The exponents first. 10 minus 1 is 9. Okay. Now we can go ahead and apply this exponent to the number. So here, if you don't have a calculator that can help you do this, you can expand it to look like this: 1 to the 9th power over 3 to the 9th power. And then this is what you would work out. So 1 to the 9th power is 1 times 1 times 1 times 1, 9 times. But 1 times itself, no matter how many times, is still 1. Okay? 3 to the 9th power is 3 times 3 times 3 times 3 times 3 times 3. That's 6, 1, 2, 3. So it's 9 of them, which is a really big number. Okay. I did work this one out before because I knew it was going to give us a really big number. So this gave me 1 over 19,683. Okay, so a huge number. Leave it as a fraction. Don't, because if you do decimal, it's way too small. Okay, so we're going to rewrite this now. So now I have is equal to -2 times that humongous fraction. So 1 over 19,683. Okay. And at this point, I mean, all we can really do if we don't want to get any decimals is multiply the -2 times the 1, because that's, remember, you can kind of put that over a 1. So the answer for this one, I'm going to zoom up a little bit, would just be -2 over 19,683, which is really, really small actually. So that tells us that that the term, the 10th term, yeah, the 10th term is really, really little. It's almost 0, okay? Yeah, that's the answer, -2 over 19,683. Go ahead and do a couple more. Actually, I think I'm going to stop the video here because it's getting kind of long. So I'll go ahead and continue the next examples in a separate video.